So this is chapter 4, section 6, number 25. So we're being asked on true or false, why or why not. Part A. So you have a continuous function, and it says, does it satisfy the conditions of the mean value theorem from -1 to 1? So you should know what this graph looks like. So let's start out with that. This is the graph of absolute value of x. But then you'll notice there's a minus in front. And so all y'all should know that when you put a minus in front of a function, it reflects it over the x-axis. So that's the opposite absolute value of x. And then you're adding 1 to this. You're taking the opposite of absolute value of x and you're adding 1. And hopefully all y'all know that it shifts the graph up 1. So now we move every point up 1, and this is 1 minus absolute value of x. So part A is asking, does it satisfy the conditions of the mean value theorem? Very important. You have to know the two conditions. When you start doing FRQs, you have to state the two conditions that must be true. It must be continuous on a closed interval, and it must be differentiable on the open interval. So here's the first question. From -1 to 1, here's -1 and here's 1. Are there any holes, jumps, or gaps in the graph? There are not, so it meets the first condition of being continuous. 2, it must be differentiable at every point in between -1 and 1. Is it differentiable at all points between that? And the answer is no, because there's a sharp point. If there's a sharp point, we know the derivative does not exist there. So therefore, part A is false. It does not meet the conditions of the mean value theorem because it's not differentiable at x equals 0. 2, or B. Two differentiable functions that differ by a constant always have the same derivative. Okay, let's talk about this. What happens when two functions that are differentiable differ by a constant? I'll show you an example. There is a differentiable function. I'll call it f of x. So we have a function f of x. To differ by a constant means my second function is the original plus some constant. I'll call it 2. That means every point of this graph is shifted up 2. So it's going to look something like this. This will be h of x. So basically you're adding a constant. So every point is shifted up the same amount. So that's what it means to differ by a constant. And the question, do they have the same derivative for each x value? Let's take a look at that. Let's look at this x value. Is the derivative the same there? Is the slope of the tangent line the same for both those? Looks like it, because the derivative is the slope of the tangent line. Let's pick another value. Let's look right here. Is the slope the same on both those? Looks like it. Let's take a look at another x value. How about right here? Are the slope of the tangent lines for those x values? Well, it's supposed to be the same. You get the idea. So it's just shifted up or down. The tangent lines will be the same at every x value. So therefore, that's going to be a true statement. If you have a function, two functions that differ only by a constant, they'll always have the same derivative. So that's true. Part C. So if a function always has a derivative of 0, that means the slope at every point is 0. The only function that's true of is what? What function always has a slope of 0? A horizontal line. If you draw a horizontal line, whoa, let me fix that because my original is pretty bad. That looks pretty horizontal. So if you do a horizontal line, if you look every single point on that line, the tangent line has a slope of 0. So that's what this is saying. If you have a function whose derivative is always 0, clearly you have a horizontal line. Their conclusion is your horizontal line will be y equals 10. No, this is false, because any horizontal line, they're saying the only one that works is the one that goes through 10. That's false. Whoops. Any horizontal line will, wow, stop that. Bad cursor. It doesn't have to be that one. Any horizontal line that will be true. So this doesn't have to be true. It could be, because the derivative of this, derivative constant is always 0, you know that. So it could be true, but doesn't have to be true. And this is saying which one of these must be true.